you are probably thinking of the endurance it takes to complete an activity, such as dancing. But actually, in physics, energy is the capacity of a system or an object to do work.
Kinetic energy is the energy of motion. An object that has motion, whether it's vertical or horizontal motion, has kinetic energy. There are many forms of kinetic energy. Vibrational, the energy due to vibrational motion. Rotational, the energy due to rotational motion. And translational, the energy due to motion from one location to another. Kinetic energy is a scalar quantity. It does not have a direction.
Translational kinetic energy is measured as 1/2 times mass times volume squared.
An object can store energy as a result of its position. This stored energy of position is referred to as potential energy. For example, a bow in its original resting position has zero potential energy. When it is pulled back, potential energy is at its max.
Like Katniss Everdeen.
Potential energy is a stored energy position possessed by an object.
Gravitational potential energy is the energy stored in an object as a result of its vertical position or height. The energy is stored as a result of the gravitational attraction of the Earth for the object. There is a direct relation between gravitational potential energy and the mass of an object. More massive objects have greater gravitational potential energy. There is also a direct relation between gravitational potential energy and the height of the object. The higher an object is elevated, the greater the gravitational potential energy.
While she's holding the ball stationary, it contains potential energy. As soon as she lets it go, it transfers into kinetic energy until it hits the ground, at which point it is transferred back into potential energy, until I slap it, which gives it kinetic energy.
Jenny and Jessica are throwing an animal back and forth, which is another example of the transfer between kinetic and potential energy.
Elastic potential energy is the energy stored in elastic materials as a result of their stretching or compressing. Springs are a special instance of a device that can store elastic potential energy due to either compression or stretching. A force is required to compress a spring. The more compression there is, the more force that is required to compress it further.
When the rubber band is being compressed, it's an example of elastic potential energy. As soon as it's let go, it's elastic kinetic energy.
All chemical compounds are composed of atoms connected by chemical bonds. These bonds contain chemical energy that was stored when the bond was formed. Coal and oil, for example, contain a substantial amount of chemical energy. This energy can be achieved when the bond is broken at a later time. Since for most compounds, this chemical energy can be stored in the compound for almost an indefinite time, chemical energy is a type of potential energy. We can store the coal or oil and release the chemical energy by burning it whenever it is needed. Chemical energy includes fossil fuels, batteries, dynamite, lighters, and several other chemicals.
Right now, the battery in the flashlight is chemical energy. When the switch is turned on, it transforms into electrical energy.
Do you ever wonder what happens to the energy stored in your body after you die? After a person dies, the energy in his or her body goes where all organisms' energy goes after death, into the environment. When a human dies, the energy stored in his or her body is released in the form of heat and transferred into animals that eat us or the plants that absorb us. If we are cremated, the energy in our bodies is released in the form of heat and light. When we eat dead plants and animals, we are consuming their energy and converting it for our own use. Food is metabolized when digested, and chemical energies release the energy animals need to live, move, and reproduce. That energy does not exist in the form of glowing, ghostly ball of electromagnetic energy, but rather in the form of heat and chemical energy. Many ghost hunters say that they can detect electromagnetic fields created by ghosts, and while it's true that metabolic processes of humans and other organisms actually do generate very low electrical currents, they're no longer generated once the organism dies. Because the source of energy stops, the electrical current stops, just as a light bulb turns off when you switch off the electricity.
You will never guess what just happened to me. It was crazy. Yeah, I know. Come on, ghosts aren't real.
Most of the energy that any dead person leaves behind takes years to re-enter the environment in the form of food. The rest dissipates shortly after death and is not in a form that can be detected with popular ghost hunting devices like electromagnetic field detectors. Woo! Now at this point, I bet you were wondering, what are the units that energy is measured in? Well, most commonly, energy is measured in joules, which can then later be converted into calories and kilocalories, which is how we measure the energy that's in the food that we eat. Also, another side note, as you can see, this ice cream is melting, which means that the temperature is rising. Thus, it is taking in more energy and causing the molecules to speed up, which is making it melt. Boom!
Mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Mechanical energy can be either kinetic energy, energy in motion, or potential energy, stored energy, position. Objects have mechanical energy if they are in motion or if they are at some position relative to a zero potential energy position. For example, a moving car possesses mechanical energy due to its motion. An object that possesses mechanical energy is able to do work. The total amount of mechanical energy is the sum of the potential energy and the kinetic energy.
Mechanical energy! Whee!
Hello, boys and girls. I'm the sun. I don't want to brag, but I'm a very important source of energy. Plants don't eat like people do. Instead, they use sunlight for energy to grow and stay alive. If there were no plants, what would animals and people eat? You people certainly need me. Long ago, when the dinosaurs were still alive, plants and animals used the sun's energy. When they died, after the sun's energy was stored in them. Today, some of these old dead plants and animals with the sun's energy have changed into coal, oil, and natural gas. When we used gasoline in the car, we were using very old sun's energy to make the car go. By myself, I can keep you warm and give you light. I can be used to heat your home and heat your water. You must agree that I'm really quite wonderful.
The sun gives off solar energy, which is a form of thermal energy. Our bodies can absorb this energy.
Electrical energy is found in nature as lighting during thunderstorms and as static electricity when we rub our shoes on the rug and touch a metal doorknob. But electrical energy is not found alone as a source of energy in nature. Electricity, therefore, must be produced from some other energy source, such as fossil fuels or uranium. Electricity is used so extensively in our society because it is easy to transport over wires from where it is produced to homes and factories. But electricity must be used as soon as it is made, since as kinetic energy it cannot be stored. A great majority of our household and industrial machines and appliances are run by electrical energy. These appliances are basically ways of taking that electrical energy and turning it into another type of energy.
This is Jenny reporting via awkward selfie video in Target to explain that wattage, as in these light bulbs, is the rate at which energy is consumed.
Power is the rate at which work is done, which is calculated by dividing work by time. The standard metric unit of power is watt. A watt is equivalent to a joule per second. For historical reasons, the horsepower is occasionally used to describe the power delivered by a machine. 1 horsepower is equivalent to approximately 750 watts. All machines are typically described by a power rating. The power rating indicates the rate at which the machine can do work upon other objects. A car engine is an example of a machine that is given a power rating. The power rating relates to how rapidly the car can accelerate. Suppose that a 40 horsepower engine could accelerate the car from 0 miles an hour to 60 miles an hour in 16 seconds. If this were the case, then a car with 4 times the horsepower could do the same amount of work in 1/4 the time. That is, a 160 horsepower engine could accelerate the same car from 0 miles an hour to 60 miles an hour in 4 seconds.